Okay, so I'm not gonna lie, I already saw the hints on this one. I'm gonna look for the algorithm to find prime numbers. I didn't change the name of the string. So there's 20, 21. Just a sec. No, I try to change the name of the string. How do I change this? Oh. There we go. Yeah, I know what a prime is. So one way that comes to mind is to define the first prime numbers, then make a condition that if the number is composed of a combination of those prime numbers, then the condition is true, and then I make the sum. I make a for loop and the sum of all the prime numbers that meet the condition up to this number, but I don't think that's gonna be possible because there's an infinite amount of ways of verifying. If the number is composed of the primes or not. So it marks all the composite numbers and excludes them. I don't understand how. So the first is to create the list with the integers. So p equal to first. So basically a for loop with I equals to. Enumerate the multiples of p by counting increments of p from 2p to m. Enumerate the multiples of p. So I have to make I equals 2 times I. Find the smallest number and that is greater than p. That is not 1. I'm not sure if I understand this. I'm gonna watch a video on this. Yeah, I thought about doing like this, but So this works. I'm not sure if it is like this that I used to do this. Let's see if this passes. There we go. I don't understand why this works. This command here. What does it do? I don't have an idea. Oh, now I think again. So it first pushes true into sieve. And it pushes true into prime. Then it creates sieve. So ij equals 4. Because it's true plus true. And this creates an array of 5 elements. So this creates an array based on the multiple of true. Each time starts with 4. And since the array starts with 0, it makes the condition true for every element that is multiple of true but undefined otherwise. And then goes back to the initial statement. So if sieve I is different than sieve I, it's gonna be 3. Sieve or sieve, I don't know what to say then. Yeah, it's kind of hard to understand. This works. Now it's multiples of 3. Oh, this creates the condition and then loops again. So this statement creates the condition from which the next iteration of I is going to be tested. Then it loops. Then it pushes.
have had several requests to show the workings of the sieve of Eratosthenes. So here goes. It's an ancient Greek method of finding prime numbers in an array or the hundreds chart. It was created by Eratosthenes, one of those Greek mathematicians from way back. We can use this to identify prime numbers up to 100. The following steps will help us find the prime numbers.
Oh, the guy must have solution to this.
Any takers? Well, it's because a prime number is any number greater than 1 and only divisible by itself and 1. So 1 cannot be a prime number because it is not greater than 1. Okay, now let's put a circle around the number 2. It is a prime number because it is greater than 1 and is only divisible by itself and 1. 2 is also the only even prime number. Next, we'll cross out all multiples of 2. To find the multiples of 2, simply skip count by 2. For example, 2, 4, 6, 8, 10, and so on. Did you notice any patterns for the multiples of 2? You do realize I can't hear you. They all end in 2, 4, 6, 8, or 0. So if a number ends in 2, 4, 6, 8, or 0, then one of its factors is 2. Next, let's put a circle around 3. It's a prime number because it is greater than 1 and is only divisible by itself and 1. Next, we'll want to cross out all the multiples of 3. To find the multiples of 3, you can skip count by 3. For example, 3, 6, 9, 12, 15, and so on. You'll notice 4 is already crossed out. That's because it's already a multiple of the prime number 2.
Oh.
The next unmarked number is 5. I'll just place a circle around 5 because
So I
it's a prime
think
number.
this is what this is then. It's crossing out the multiples of the prime numbers. If it's not on here, then it pushes to prime. And if it is here, it's gonna create this different array. Based on the condition.
Next, let's skip count by 5s. Do you notice any patterns in the multiples of 5? I sure hope someone got that. They all end in 5 or 0. So if a number ends in 5 or 0, you know one of its factors is 5. 6 is not a prime number. Do you know why? Because 6 has more than 2 factors. Its factors are 1, 6, 2, and 3. All the multiples of 6 are already crossed out, because if a number is a multiple of 6, it already had factors of 2 and 3. Looking at the table, our next unmarked number is 7. It is prime because it is greater than 1 and only has 1 and itself as factors. We'll circle it and then proceed to mark its multiples. Most of 7's multiples are already crossed out because those multiples have more than 2 factors. 8 is not a prime number. Do you know why? Because 8 has more than 2 factors. The factors of 8 are 1, 8, 4, and 2. 8's multiples are already crossed out because if a number is a multiple of 8, it also has a factor of 2. 9 is not a prime number because its factors are 1, 9, and 3. It has more than 2 factors. All of the multiples of 9 have also been crossed out because they have up between 2 and 100 are 79, 83, 89, and 97.
Welcome back. Today we're going to do the sum of all primes. Prime number is a whole number greater than 1 with exactly 2 divisors, 1 and itself. Search ask. And so, yeah, this one, I've done this one a few times, so I'm just going to, first off, we want to have a function that says whether or not a number is prime. So we're going to call it function is prime. And in there, we're going to hand in a single number. So yeah, well, we want the counter. We're going to set something. We're going to set a counter to be equal to, let's say 2, because we can't do 1 because every number is divisible by 1. And then we want to say while the counter is less than or equal to the single number, we're going to, well, first off, we should make sure to iterate the counter because otherwise we'll have an infinite loop. So we're going to go counter plus equals 1, and then if the single number divided by the counter is equal to 0, then we want to return false, because the number is evenly divisible by the counter, and the counter is, and therefore it is not, oh, we don't want this to be equal to, we want it to be just less than, because the counter would at some point become the single number, and then that would always return false. And so if we go all the way from 2 all the way up to the single number minus 1, and we don't find it evenly divisible, then we can return true, because it is a prime number. Okay, awesome. So now we have a number. One way that I can check this is like a console.log, and I can say is prime. Let's say is 2 prime. True. Is 3 prime? Should be true. Counter is not C-O-U-N-T. U-N-T-E-R. There we go. 3 is prime. Is 4 prime? False. 5? True. 6? False. Cool. So our is prime function is working. Let's set, we're going to make this the result, and then the sum of primes, and then we can console.log the result. What I'm doing here is just running the result of us calling this function on the number 10. So right now it's just returning 10, which is incorrect. So what do we do here? Well, we want to have, we're going to do it very similar to the way we did here. Here we want to say, again, we're going to have a counter, which is equal to, well, I guess first off we should just say, protect against this case. Like, if the number is less than or equal to,
not checking for 9.
1, we should just return false. I'm not even sure if this is necessary, but the idea is that if somebody passes in like -10, we just want to return like, or at least like, not numbers lower than 0 don't work here. Right, numbers lower than 0 don't work here, so -10 won't work. And so that's just a side case. I don't even know if this is required on this, but I'm gonna put it in anyways. let's see here. So now what do we want to do? We want to have a counter which iterates up, right? So a counter is equal to 2. We can let the counter equal 2. And then also we're trying to get a sum, so we'll let the sum equal 0. And then let's return the sum, because that's actually what we're going to want to do. So, I mean, we can just do another while loop, right? While the counter is less than the number, we want to, first off, counter plus equals 1. I always try to iterate the index of a while loop immediately, otherwise you get in these crazy infinite loops and it causes your computer to act strangely. But, so we're iterating up. So now, we can say if the counter is, so if the number, if num, modulo of the counter is equal to 0, then we know it's even, right? Wait a second, I'm just doing the same thing. The sum of primes. Oh no, if the, if the counter is prime. So I can say if is prime counter, so that's like if the counter is prime, then we want the sum plus equal. We want to add the counter to the sum. Okay, so now we're getting something, right? Sum of primes of 10 should turn to be 17. And if we do 977, the result should be 7. Okay, so I've got something wrong here. This isn't quite right. If we run the test, these two will pass and this one will fail. So what's going on? Okay, so what's going on is the counter, I think if we were to go console.log is prime, and we did 977, I think we get true. Yeah, so 977 is a prime number, but we're not adding that. So I bet that 977 minus plus this number would equal this number. The reason that we're having this problem is that the counter is stopping just prior to the number. So if we make the counter equal to the number, then we're going to get 73156. So we were just missing the last prime number in the sequence. We're on the tests. We'll see the pass. Okay, cool. This is a really common computer science situation. There's a lot of cryptography. Prime numbers are involved in a lot of cryptographic work, things like that. So understanding this stuff can be really useful. There's a ton of different ways to do this. I'm sure this isn't the most efficient one. There's a lot of different ways that we could refactor this. Instead of using while loops, we could use other things. But this is just a good way to move through this exercise. So hope you guys enjoy this one, and we'll see you in the next one.
So this is using cryptography.
First thing I'm going to do is declare a constant called n, which will be the number I'm going to calculate the sum to. In this case, I'm going to declare an empty array called prime, and then fill it with the value true. Squared is less than n. If the current instance is prime, trigger a loop. This is iterating through the list, changing values to false. I'm going to increment the p variable. I'm now going to set the first and second instances in the array to false, because 0 is not prime and 1 is not prime. I'm going to create a counter value. It's prime.length minus 1, the index is start at 0. If the current instance is prime, increment the variable. Lastly, display the result to the user.
Yeah, no, understand this very well.
Need a professional website? I created one for our startup using Wix. Let me show you how I did it.
Hey guys, welcome to another JavaScript challenge, and this particular challenge will be a doozy because our function will test for prime numbers. As always, if you want to solve this challenge yourself, just pause the video and resume once you are ready to compare the results. So, prime number. And each and every time, whenever you're going to be dealing with something math related in your challenge, it's probably a wise option to figure out, well, what it is as far as math is concerned. So what do we mean by when we say, okay, so we're going to be testing for the prime number? Well, the prime number...
Let me read the next challenge on these loads. Yeah, sorry about that. The smallest common multiple. So remember that there is a way to find the smallest denominator, common denominator, but I don't remember exactly how. It can be evenly divided by both, as well as by all sequential numbers in the range between this prime. I don't understand this very well, the way that it's phrased. Oh, it can be bigger. So it has to be divided by every single number between the two inputs of the array. So I need to make an array with all the numbers from one to the other one, and then try to make a condition that makes a number go through, be divided by all of the numbers in the array that was created, and have the remainder as 0. And if it's true, I push it to another array. And stop the loop. So it has to be the smallest common multiple of the two that is also divisible by the numbers in between them. So in this case would be 6, because it's multiple of both, and divided by 2. 1 and 3. I think I understand what it's asking me to do.
We can only divide evenly if we divide this number by itself or by 1. So let's say number 11, which, by the way, I'm going to give you a hint that this is
Why is this taking a long time to load?
Divide 11 by, and you're going to get an even result. So let's say 2 would be 5.5. That's not even. We would need even. Again, 3 would be the same scenario, 4, 5, 6, and 7. So what we're having at the end is that we can only divide this evenly if we divide this by 1, or actually by the number itself, the number. We can also figure this out if we're just going to go ahead and do a quick Google search, and you can read here the official actually function declaration, or not function declaration, actually a prime number.
Yeah, I understand all that.
So we're going to say here modulus. Now, why we would want to use modulus operator? Because modulus operator will going to give us the remainder of the division. So I could say, okay, so only up to the 10, but then I'm going to get a remainder of 1. And just to show you how this basically would work.
Pare agora o que está fazendo e preste atenção.
Fucking ass, man.
So we can say console log 11 modulus, and let's just copy and paste it a few times just so you can see the result. So 11 modulus 2 would give you a remainder of 1, 3 would give you a remainder of 2, and then 4, let's say, would give you a remainder of 2. Because we can get 2 even numbers of 4 within 11, but then we get a remainder of 3. Now, same way for dividing this, let's say, by 8. So 8 modulus 2, this will going to give us the remainder of 0, and the same would work obviously with 8. And we don't care much about 3 here, but just to give you an example that, again,
Understand this as well.
and then I'm going to be looping all the way up to the number. Now, obviously, I don't want to make this equal to the number, because I'm just testing all the numbers that are between 2 and less than that number. Because even though this will be a prime number, if it's going to be the actual number, when we're going to be iterating, I could say if number modulus and that particular iteration, if this is equal to 0, meaning that if we don't get a kind of remainder, so if the remainder is 0, then I know that this is not obviously a prime number. Because like you saw with an example of 11, if I was trying to use the modulus operator, I was all the time getting some kind of remainder. So I could say, okay, so return false. So this particular number will not be a prime number, because somewhere within this loop, we will going to get, obviously, that this will be equal to 0. So that is false. And last but not least, if the number will in fact be a prime number, we're just going to return true. So what do you see here? Well, we can proudly see that is prime 8 returns that this is not a prime number, which is correct. Then 11 is a prime number. 121 is not a prime number, and last but not least, 127 will be a prime number. So this probably will be the most popular case that you're going to see, the most popular solution, because it's usually in everywhere as you're looking for this particular challenge. Now let's make things a little bit interesting, because one of the problems right now is that, let's say 127 is not a prime number, correct? But what we're doing is we're iterating from number 2 all the way to 126 just to check that. And in essence, we're unnecessarily using way too many loops than we would have. And in fact, there is a bit of a better way how to solve this problem. Basically, much quicker, where we don't need to use so many loops. Now, that better way is using what? Well, we can use a square root. Now, the main idea would be very simple. So I'm going to set up a variable, and I'm going to say root, and the root will be math ceiling. So I'm going to make sure that I always round up. I can always use math, and let's say square root function, and I'm just going to get a square root of that number. Now let me just console log this root, just so you can see what's happening. And we have the square root obviously here. In this case would be 3, for 8, then we have 4, 11, and 12. And the idea is like this. So if we have, let's say, a number, and if we take a square root of that number, and if we iterate from our case number 2 all the way up to that square root, but the difference would be that we do need to set this equal to the square root. So I'm going to write equal to whatever number we're getting. And if we're still cannot find here that we can divide evenly this number by the numbers between 2 and equal to the square root, so if we do our loop from 2 all the way up to the square root, and we still see that we don't get any reminders of 0, that means that also this number is not right. So as you can see in our case, we're saving what? Well, in the first case, we were iterating from 2 all the way to 126.
I think I understand, but I don't understand completely. But I'm just gonna let it go and go to the next one. I sort of understand the logic behind it. So it has to be multiple of both, and it has to be divisible by every number. So first thing, let me close the window so that it's noisy. First thing that comes to mind is to find the multiples. Find the minimum multiple of both of them. And put that into an array. But the issue is that it has to be divisible by all the numbers in between them. So the first minimal multiple is not necessarily going to be the correct one. And if I created an array of all of them, it's going to be too big. Like, it's not logical to do that way. So I think it has to be both conditions in the same loop. First tests if it is so first tests if it is a multiple of both. Then checks if it is divisible by all numbers in between them. And if it is, returns that number. So I need to create an array that contains all the values between the two numbers that it gives me, but they are not necessarily in order. So I'm gonna make two conditions. First, create a different array. Then I'm gonna create two conditions. So if R1 is bigger, which is gonna be like the natural, like this first example, because 5 is bigger than 1, I'm gonna loop through the difference between them. But I'm not sure. Yes. So why is giving me 4 arrays? Give me just 1. And then I'm gonna make a same condition, but the other way around. And let me switch and see what happens. Yeah. Now I just need to find a way to make this only 1. I think I'm gonna put this on here to see what's happening. Oh, it's because I put it inside of the loop. It is right, but the console.log is what's making it show up that way. Yeah, there we go. So it is creating only one array, but it was printing every time it pushed. Okay, so now I have the array with the numbers, all the numbers between the two inputs that's gonna give me. And now I need to create a loop that tests for both, for multiple, common multiple of both. And then if the condition is true, it's gonna divide by the other, it's gonna loop through the other array to verify if it's divisible by all the numbers. So create another loop. And the issue here is I'm gonna need to know which one is the biggest one. I'll be right back, though. I'm gonna go to the bathroom. an easier way to verify this is gonna be if I make there's also a math.max function, if I remember correctly, that compares both numbers and returns the max, the biggest one, but I don't think I'm gonna use this. So because I created this array with all the numbers in between, it means that the last number of this array is gonna be the biggest one. So it's gonna loop until it reaches the biggest one. And now I have to verify if the number is a multiple of both the maximum and the minimum, which is gonna be 0 and -1. So it has to be, in order for it to be multiple of both, it has to be divisible by both. Right? So maybe I don't need to do this. The biggest and the smallest I can check for all of them right away. And this doesn't actually loop through just through the array, it has to loop until it finds. That's the problem. The number is not going to be in the array, it's going to be bigger. It's the other way around, I think. Yeah, I need to loop through all numbers. And then I need to test let me make this different. just gonna type like this. So I think about it. It has to be a nested loop, I think. For each number, I'm gonna run this loop. I was gonna test inside of all numbers if it is divisible. So yeah, that should be a nested loop. So this needs another condition. The problem is that it can be any number, right? That's the issue. So if number divided by is equal to 0, return. This is gonna return all numbers. We're gonna return the first number, actually. And then I need to test for all of the numbers in the array. I'll be right back. Should be coming. I'm thinking about this the wrong way. Because I'm testing for if they are divisible by all numbers first. And what I need to do is find the smallest multiple common first. But isn't the same thing? Because it's gonna be the smallest common multiple of all of them, if it is divisible by all of them. So this is not gonna pass for sure. Because I'm returning the first number. The tests, so I need to test all of them and then return. Instead of returning the first one. I'm gonna loop through the array and divide the number looped through. So I should put into words what I'm thinking about. So I pick up the number and divide it. I'm gonna pick up a number and divide it by all of the numbers in that array. And check each time if the remainder is 0. If the remainder is 0, I keep going. If it's not, I break. and go to the next one. So for each number it's gonna be a loop. So here should be a break, I think. No, because it has to be all of them. Not just the first one, but the remainder is 0. So if the remainder is 0, I want to keep going inside of this loop, the J loop. If the remainder is not 0, I want to go to the outer loop. How can I say this in code? So I guess I don't need to specify if the remainder is 0, because it's gonna keep going. I just need to specify if the remainder is not 0. But then it's gonna break at the first. I'm not sure if it's gonna keep looping. That's the issue. Yeah, potential infinite loop detect on line 16. That's me. This is not changed. But that should be like this. Let me try. This condition is wrong, but I don't know how to. Maybe it's not like this when I do it. has to be divisible by both numbers. The max and the minimum. So 1 times x and 3 times x has to be equal. I'm thinking about how to start from the numbers and not from the numbers in the array, not from the number on the final number. Like how can I test if it's multiple of both 1 and 3 instead of testing the number on the other way by dividing by 1 and 3. One times x is gonna give me a number, 3 times x is gonna give me another number. And it has to be equal. No, it's not gonna be equal. No, this doesn't make sense. Because 1 times 6 is not gonna be equal to 3 times 6, obviously. So I have a number gonna be divided by both the smallest one and the biggest one. If it is divisible, it's the it doesn't make sense because it has to be divisible by all of them anyway, right? Because I'm gonna test that later. And we can use map or filter. So why this is wrong? I'm trying to remember. I'm trying to think about if this makes sense or not. Because I'm looping through all numbers already. Maybe the loop is not necessary. Like I can filter the array by checking the condition. And probably the way I'm typing this is wrong. I was returning 1, which is not the case. It's the other way around. I'm gonna check if the number is divisible by the element. I'm gonna filter, but maybe I need to create a different array. I'm gonna give it another name to this, I think. Now it's different. So it's giving me 1, 2, 4. No, that doesn't make any sense what I'm trying to do, actually. Now that I think about it. I'm filtering all numbers already. That's not what I want to do. Based on the number, the remainder of a number divided by the element of the array is going to be equal to 0. I think I'm thinking about this backwards somehow. It's not filter, doesn't make sense. Should do it like that. Maybe if I just multiply all of them, is gonna be the smallest. So if I forget about this thing. And if I just make something like this. Yeah, but it's giving me 120. Should give me 60. So it's not necessarily the same. It's multiplying all of them. And 3 times 3 is 6, times 4, 24, times 5, 120. It should be divisible by all of them, but not necessarily the multiplication. It should be super easy to do, but it's probably something about the math that I don't remember. It should be simple. Just look through the array that I created by testing the numbers, and if it's divisible by all of them, then return the number. But if you start the array from the greatest to smallest, then you can use the first two numbers as a first check for the smallest common multiple. This is because they are more likely to be the smallest common multiple than the lower numbers. So it's telling me to sort the other way around. The thing is, I don't want to check if it's only divisible by each number, by one of the numbers. I'm gonna check if it's divisible by all of them. That's the issue I'm having here. Hey. I'm trying to solve the free code camp challenge. This one. I have to find the smallest common denominator, common multiple between all these numbers from these two values here. Yeah, the greatest common divisor. Post the question in chat, please. Well, it's not really a question, it's more of like this statement here. The thing I'm stuck is that I want to test if the remainder is 0 for all the numbers, not just one by one. Like my idea is to loop through the array that I created here. Let me comment this out. I want to loop through all these values and test the number. So for example, 0. I test if 0 is the remainder is gonna be 0. Yeah, I actually can't be 0. It has to start from 1. But if the remainder is 0 for one value, I want it to keep going, and if it's not 0, then I want it to stop. But so I only want to return the value when it's divisible by all of them. That's the issue I have. Yeah, the question is here. Find the smallest common multiple of the provided parameters that can be evenly divided by both, as well as by all sequential numbers in the range between these parameters. The range will be an array of two numbers that will not necessarily be in numerical order. For example, if given 1 and 3, find the smallest common multiple of both 1 and 3 that is also evenly divisible by all numbers between 1 and 3. The answer here should be 6, because 6 is divisible by 1, 2, and 3, and 2 is between the 1 and 3. And here are the test examples that is gonna go through. So the issue here is that if I test if it's divisible by 0, if the remainder is 0, it's gonna stop at the first condition, at the first number that gets 0 as the remainder. Like the way I was trying to do before. Yeah, actually let me start at 1. Maybe that's why it was an infinite loop. I was trying to do like this. No, it's JavaScript. I know Python is very similar actually too. From the little I know. So I was trying to do like this. But the issue is that's gonna return the number then. It's not even console logging because it's returning first. Like it's gonna return the first number, I think. Yeah, it's gonna be 1. I'll try to solve with you. Yeah, do you understand what I'm trying to do here? Or if you don't, just ask and I'm trying to explain. Yo man, good to see you. First time I catch you on stream. Oh yeah, hey man, what's up? Have you done this sublimation? These coding challenges from Free Code Camp? I remember you told me that you were doing them a long time ago. I think I'm gonna put this on the tutor and try to visualize what's happening. I've never done this challenge. I've solved this problem though. I just did the web dev part a little. What are you doing right now? I'm doing the JavaScript challenges from Free Code Camp. I'm on the algorithm scripting part. This is the issue it returns. Are you still here, Hotshot Dragon? How did you solve this? Like, what I'm trying to think is I wanted to test for all of the numbers, to test this condition for all the numbers in the array, but to not stop it in the first one. But if I don't put return num, then I don't think it's gonna test the condition. I did it last year. Now just give me an infinite loop because it's never gonna stop. It's never gonna find any number. Maybe I need to put a break on side so it's not an infinite loop, but it still doesn't solve the condition part of the question. How can I make it so it only keeps going if it is divisible? Did you do the web design parts too, or did you start with JavaScript? No, I did it all the way from the beginning. I'm just following the natural progression that they have there. I'm not sure how was it when you did it. X equals int, input, enter first number. If x greater than y, greater equal x, else greater equal y. That's the solution you found? Tries for two numbers on. Yes, I do have Discord. Enter second number. Yeah, I don't understand this code that you put there. Is it on JavaScript, this language you wrote? Or is it in Python? So the first is checking for which number is greater, then it checks if the number is divided. Oh, it checks for both conditions. I think I kind of get it now. But I'm not sure how to translate that into the JavaScript thing. Because the number is not necessary, the number is always gonna be bigger than both of them, you know? Like you can make x, for example, if x equals 5 and y equals 1, we're is gonna be equal to 5, but the common denominator is gonna be greater than 5. If you understand what I'm saying. It's gonna be 60. I think the filter method should be, I should be able to use that to verify a condition, but which was what I was trying to do before also. But then it's gonna filter every time, and then it's gonna stop in the first iteration for number equals 1, num equals 1. And that's the issue I have there. Because I don't necessarily want to filter the array, I wanna use the array as a filter, which is different. Maybe I can create a different variable and then make the condition based on the variable. Like I divide the number, I make a variable equals the number divided by all numbers j. So the variable is going to take a different value every time. You remember if this is how you divide things. And still in infinite loop, but maybe if I put return num here. No, it's not gonna work either. So result's gonna be equal to number divided by the number that is on the array all numbers. Don't worry, man, it's fine. Like, this is how you learn anyway, right? Just trying and failing. Get a evidence. It's 2 AM here. I hear the sound of some sound, but of the stream, but I'm not getting any notifications. Let me see. Oh, thanks for the follow. I'm not sure why it's not showing up. I'm not very good at this. Oh, anyway. I will look for it later. Yeah, I already read this. Connect me at Discord, Hotshot Travel. I will later the stream. I think I already showed my username on Discord on a previous stream, but I'm not sure if it's a good idea to put it out there, you know. So this makes the result equals the number, which is going to be 1 divided by these numbers here. And when the result is different than 0, which is going to be when the remainder... Oh, that's the problem. It has to be the remainder, not the... Oh yeah, but the result is the remainder of the division. No, the result, not the remainder of the division, that's the issue. Because 1 by 1 is equal to 1 and not 0. So maybe if I just put... But it's the same thing, but different way. I don't care about that. People here don't use it at all. Under relax, I guess, try to print things, to debug it, don't do it in mine. I think I'm gonna use the Python tutor thing to visualize what's happening. But I get a sense of... I think I know what to do, I just don't know how to translate it in code. It makes sense. Or maybe I need to do it on a totally different way, and then I'm gonna have to erase what I've done so far. If you want to learn Python, I'll send you some good course. Yeah, sure, man. Just send me. I will learn Python after I learn JavaScript for sure. But the first thing I'm gonna do is just finish these free code camp challenges all the way through, I think. Just so I have a good base, and then I'm gonna see what happens from there. Let me open on this browser. MIT. Doesn't these things get outdated really fast though? I guess the fundamentals probably never change, right? Yeah, I'll look into it. Maybe I can save this playlist for later. There's so much stuff out there. This one's not, I have read it from here only, yeah. MIT OCW is a mine in Pitelcho. What do you mean by that? Is a gold mine? What is OCW? How can I do this? I want to filter the number through the array. Divide the number by all the elements of the array. And then return it. MIT OCW and NPTEL separately. I'm guessing it's kind of a course or something. Oh, open courseware. One thing that I'm kind of concerned also is doing too many tutorials on courses and not actually trying to build anything. Because everybody says that the best way to learn it is to try to build an actual thing. But I'm not sure when I'm gonna be ready, I'm gonna have enough fundamentals to actually build an entire software or application or something. So I feel like with what I have right now is not too much yet to build an actual thing. Because everything I can think about building is it seems like it should be complex. Like I want to build a poker software, I want to build things to upload YouTube videos and things like that, and just see what I can do, you know. Courses here will strengthen the fundamentals. The one I sent you of Python is for beginners. Yeah. Is it free? Or do I have to pay? I guess I can look here. Yeah, nice. I'm definitely not gonna do them now, but maybe later. For now, I'm gonna keep on track on this thing. Should not lose focus. This one. Copy link location. I did one EDX course, free course, before I started these challenges on Python. And everybody on the comments of the course said that was really good, but it was really confusing to me. How node? What is how node? Yeah, bye man, thanks for the insight and the suggestions. Oh, this is actually interesting because it has like the themes and stuff. Wait, is this all on computer or? Oh, it's just different fields, I think. Yeah, I'm gonna save this anyway, I think. How old are you? Python or Java? JavaScript. I'm 26, soon 27. Practically 27 already. Yeah, I just can't think about a way to get out of this. This is completely irrelevant. I can just do like this. But I don't want to stop on the first one. Maybe I'm just gonna duck the code. So if I just wanted to check for the condition and forget about everything else. I have an array and I want to check if a number is divisible by every number in that array. Means B divides A. Are you sure? I think it's the other way around. Yeah, B divides A, yeah, that's right. But the number that I'm testing is the one that's gonna be divided by the numbers in the array. And also, in this example should be 60 divided by 1, then 60 divided by 2, 60 divided by 3, and so on. And if it is divisible by all of them, then I return the number. But if it's not, then I need to keep the loop going. And that's the issue. Because if I put this condition here, it's gonna stop in the first one, and then it's gonna give me the answer 1, because the remainder of 1 divided by 1 is 0. And when I check for the remainder of all of them, that's the issue I have. So if it's not 0, then it should go to the loop again, but and the issue might be the way I'm structuring this loop also. But I can't think about any way of doing that is not like this. Like, unless I do completely different and I do it backwards, that I start by trying to figure out if it's like I multiply by every single one, and then I figure out if it's the same. But that's gonna be true. I feel like that's not the right path, because it's too complicated and not efficient enough. So let's think if I just have one number instead of trying to loop through all of the numbers. How would I do it? Let's say 10. I divide 10 by... I take the number, I divide by... the number every single time. Maybe I just need to check if it's different than 0, then I break, but I think I already tried this. And if it's not, keeps going, but I'm not sure if it's gonna return 1 anyway because I have return inside of the loop. And the issue is I don't wanna, like, as soon as it is divisible by all of them, then maybe I just put that way I just check for the last one if it's, because if it's gonna look through all of them anyway, right? So maybe I don't need the first condition. No, but then it's not going to necessarily test for the previous ones. I think this should work. Then outside of this, I'm gonna make another variable, I think. I'm gonna call it count. And then I'm gonna make number equals count and return count instead of number, so that it doesn't stop the loop. But I don't think it makes a difference actually. Maybe if I just erase this. And it's giving me potentially infinite loop because the number is too big, but I don't see how to make a condition that makes it not really big. I feel like this is probably wrong, but let's test it out anyway. Yeah. I'm gonna put this on the tutor and see what happens. I'll be right back. Let's close the window. So I feel like I'm gonna stop for today. I think I'm gonna have to redo all of this stuff because I'm probably doing things in the wrong direction, taking things in the wrong direction. So probably the right way to solve it is backwards by multiplying first the numbers instead of trying to find the one that's divisible by all of them. So I don't create this infinite loop thing. Like I need to multiply by all of them and then see if it's equal. Yeah, that's actually makes a lot more sense, I think. But then I'm gonna have to create a different array for every single number. And that's the issue. Because I'm gonna have all multiples of 1, all multiples of 2. And then I'm gonna have to find the common. I don't think this is the right way to go about it. Let's see how long I've been here for. Yeah, almost 3 hours already. Which is more than what I planned to do. I definitely think I'm close though. Very close. Be using the same logic as the CIF one from the previous challenge. Where it creates a different array. And the thing is, I forgot about that one array. Actually,
When Johnny said he needed...
Hey guys, welcome to another JavaScript challenge, and this particular challenge will be a doozy because our function will test for prime numbers. As always, if you want to solve this challenge yourself, just pause the video and resume once you are ready to compare the results. So, prime number, 4 by 1. So let's say number 11. Here in this case, we're going to say return false. So why we're doing that? Well, because we can see that 1 is not a prime number. Now, why we would want to use to get a reminder of 1. And just to show you how this basically would work, so we can say console log 11 modulus, and let's just copy and paste a few times. So
oh, instead of putting this number, I can actually put times. I don't know if this is possible, but that way it's gonna loop until, because obviously, well, actually, I'm not sure. Instead of 0, should be -2. No, that doesn't make sense. I was thinking about making the biggest number the multiplication of all the numbers in the all numbers array, but I'm not sure if it works because the minimum divisible number might be bigger than that. But I'm not sure if that's true mathematically. Because if it's multipliable by all of them, it has to be divisible by all of them. Yeah, so it can be smaller but not bigger, I think. So how can I make this I could use reduce, but I'm not sure if that's good to put inside of this loop thing. Maybe just this works. Yeah, it's not command. So this I think should be better than the previous thing I did. Because now it's gonna loop through until 120 and not that giant number. Let me take this. No. So happens. So at least it's looping through the entire way, I think. But it's not going again. It's stopping at number 2 equals 2. Oh, I can create a variable here and make it equal some numbers. Oh. I think this way works better, because I still think it's wrong, but this is better than before. No, now it's looking a lot more. Okay, so let's see. So it's giving me 15. Oh, because it's not the sum, it's multiplication. Now it should give me 120. And maybe it should be, and I think it's still wrong, but potentially infinite loop. This is weird. Shouldn't reduce give me the factorial of all of them? An easier way would be to take the factor of the last number because it's gonna be the highest number. Yeah, it can be done with the for loop. Yeah, dot reduce. Maybe. And so it is 120. So why is giving me an infinite loop? So this is not the problem. It's probably the condition inside of this here. It's looping until 120, but inside is going forever. This should give me an infinite loop. Yeah. least I'm making progress, I think. And I should return, shouldn't return. Oh, actually I should. So maybe instead of creating the loop, I create the filter. Yeah, I don't know, I think I'm spending too much time for today. I'm gonna go back another day to solve this for fresh hat. But I think I have an idea of how to do it, so it's probably with the filter method, and I'll try it another day. So yeah, see you.